Hi everyone, my name is Trisha and this is my YouTube channel called Knowledge Sharing. So today I made a machine learning project called Digit Recognizer. So basically in this project we have performed stochastic gradient descent optimizer and the Adam optimizer. We have used these two to find out an accurate recognizer of digits, and then finally we performed regularization to prevent overfitting. So this project basically consists of 4 layered and 5 layered neural network models. So let me show you the code. So I have basically coded this entire thing on Jupyter Notebook. I have imported two datasets from Kaggle, the test.csv and the train.csv. Let's look at the code. So first I have imported the normal libraries pandas, numpy and keras. After this we have performed the basic, to see the head of the training data set, and then finally I show the difference between the training and the validation set. This allows us to divide the training data set into something called the training data set and the test data set. After this we have performed data cleaning, normalization and the selection of the data. So here we have started the model fitting. So first we want to make a model which has 6 layers, as in first is the input layer, 4 hidden layers, and lastly the output layers. So this is the model summary for it. These are the total number of parameters, these are the trainable parameters, and this is the non-trainable parameters. We have set the learning rate as 0.1, training epochs as 20 and batch size as 100. Now for this we have used the general stochastic gradient descent optimizer. So in this this basically, the stochastic gradient descent optimizer is used in machine learning projects to find model parameters that correspond to the best fit between predicted and actual outputs. So since this is the first model, we just get the accuracy of almost 97%. After this we want to try to see if the accuracy can be higher, so we use the Adam optimizer. The Adam optimizer is commonly used in deep learning. It is an extension of stochastic gradient descent optimizer and is designed to update the weights of a neural network during training. So again we keep the same details, and we perform the Adam optimizer, which shows that the accuracy hasn't really increased that much. It's barely 98%. Now we edit the learning rate to 0.01 to check again if changing the learning rate would increase the accuracy. But it doesn't make a difference. It's still only 97. It's close to between 97 and 98. Now we are again we want to change the learning rate to 0.5 and check if the accuracy differs, and there's a very small difference. If we are being honest, it's only 0.9744 as in 97%. So now we decide to change the number of layers. Now this is a 7 layer model which has 1 input layer, 5 hidden layers and 1 output layer. So this is the summary of the model which we just made. So now we use Adam optimizer again to check the accuracy, because Adam optimizer is obviously better than stochastic gradient descent optimizer. So now we see the accuracy is just 99%. It's barely increased. It's very close. We're not getting a complete accuracy. So since the accuracy hasn't increased that much, we'll go back to the 4 layer neural network diagram. So this is the final diagram after editing everything, and again finally, just for a last final result, we perform Adam optimizer again and find out that the accuracy is 0.9865 as in 98%. Now we have found out the complete summary of all the test trials that we have found out and made it into a tabular form. Finally I have converted this test underscore predict tabular form to mnist underscore submission.csv file. So this CSV file is stored here. It contains all the values that were taken as the output values and the input values for all the models while we were testing it. So it's a really long table. So I really hope you guys like this video. I hope you guys found it informative. The code for this video along with the datasets is available on my GitHub account. The link is provided below. Thank you so much for watching. Like, share and subscribe.